Let's take a look at some of the frequently missed problems on our Step 3 quiz. So in the first one here, we have the power to a power property that we have to apply. This -4 outside here needs to go to each factor. It goes to the q to the 4th, to the p to the -3, and to the -3 itself, because those are separate factors. Things that are multiplied together are factors. I want to make sure that you don't get that confused with something that would look like this. That would be different. Because of this plus sign, we would not be able to distribute or apply that exponent. We would have to use an expansion. But when we have just things multiplied together, we have a -3, we have a p to the -3, and we have a q to the 4th, and they're all multiplied together. You can take that exponent and apply it to each piece. So when I do that, I get -3 to the 4th, p, multiply those exponents, to the -12th, q to the 16th. I have negative exponents, so I want to put it over 1 because that p value needs to move to the denominator and become positive. And then the only thing left is to deal with this -3 to the 4th. That's -3 times -3 times -3 times -3. Negative times negative is positive. Negative times negative is positive. So we end up with a positive 81. Q to the 16th over P to the 12th for our final answer. On this next one, a lot of people wanted to take this invisible -1 out front and distribute it to the 4w cubed and to the z, but we don't do it that way because there's no plus or minus right here. This is all one term. It's one big term. Really, we don't even need the parentheses. We could have just written 4w cubed z to the -5th times 8w, and that's where we do need the parentheses, squared. Because we need to take this exponent and apply it to each factor. So again, I have -4, w to the 3rd, z to the -5. 8 squared is 64, w squared. I put all of it over 1 because the z to the -5 needs to move down to become positive. And then I can multiply my coefficients. -4 times 64 is -256. I can multiply my w factors, keep the base, add the exponents, and z to the 5th is on the bottom. This next one, I want to show you two different ways that you could tackle this problem. The first way is to take this exponent and apply it to each factor inside. That's one option. When we do that, we end up with 2 to the -2, x to the -6, y to the -4, over -x to the -4, y to the -10. And you might say, well, why did you do this? Well, I could do it a different way. I could just say x to the -4, but that -1 would also go to the -2 then. This -1 right here, I could keep it separate and distribute that -2 separately. So here I gave it to the negative sign, or the invisible -1, and then I gave it to the x squared, which made it x to the -4. I kind of like that way best because I think it keeps track of the negative sign better. Now I'm going to move everything that has a negative exponent. So 2 squared moves down, x to the 6th moves down, y to the 4th moves down, -1 squared moves up and becomes positive there. Just the exponent, not the negative sign in the number. X to the 4th and y to the 10th. Now we just need to simplify by canceling out our common factors and multiplying. So -1 squared is -1 times -1, which is +1. I don't even need to write it. On the bottom, 2 squared is 4. I do need to write that. Where are there more x's? On the bottom, how many more? 2. Where are there more y's? On the top, how many more? 6. And that's our final answer. This next one, again, we don't really need these parentheses. They're non-essential because we don't have any exponents outside of them. We aren't trying to distribute anything. So I don't really need those. I do need them right here, however, because here I'm taking that exponent of 4 and applying it to the x factor. So instead, we're just going to try to simplify. 3 times 5 makes 15. X to the -2, y to the 3rd, x, y to the -8. I put the 5 and the 3 together, and then I just wrote all the other 4 factors next to it. And on the bottom, we get x to the -12th, y to the -2. Next, we need to move anything with a negative exponent. 15 is to the first power. It doesn't move. It's not connected to this x because all of these terms are simply multiplied together. 15 times x to the -2 times y cubed times x times y to the negative. They're just multiplied. So the factors can move independently of their coefficient. So the x squared moves down, y cubed stays, x stays, y to the 8th moves down. Looking at the bottom, x to the 12th moves up, and y squared also moves up. And now I need to just combine things a little bit. These would make x to the 13th. The y's would be like y to the 5th. So I have 15. How many more x's are on top? 11. 5 y's on top, 8 y's on the bottom. That would leave 3 y's on the bottom. Now I just remembered, I promised I would show you a second way to do this problem, and I forgot to do that. I'm going to erase right here and show you a different way to do this last problem. One option when you have a negative is to put it all over 1 and take anything that has a negative exponent and move it. But when you have a fraction raised to a negative power, another option is to just flip the entire fraction. I'm just going to rewrite it. -1 x squared y to the 5th, 2x cubed y squared, and that instantly changes this exponent to a +2. It's kind of like, do you want to distribute it and then move everything, or move everything and then distribute it? It's 6 1/2 dozen in the other. We're still going to apply this power to every single factor inside. So we have -1 squared, x to the 4th, y to the 10th, over 4, 2 squared is 4, x to the 6th, y to the 4th. And simplifying, we end up with y to the 6th over 4x squared. Same answer, just a different way to do it. It's kind of a little fraction trick. On this next one, we are multiplying a binomial times a trinomial. When we have a binomial times a trinomial, the box method is extremely helpful. So I'm going to write my binomial on the side, m, 2k, and my trinomial across the top, being careful to keep the signs with their terms, with the numbers. M times m squared is m cubed. Multiplying these, I get negative 2m squared k. Multiplying these, I get 4mk squared. Multiplying these, I get 2m squared k. Even if I had written 2km squared, that's the same thing. I'm just trying to be consistent. I'm putting the m first and the k second in each term. Doesn't really matter how you do it, just try to be consistent. Negative 4mk squared, and finally 8k cubed. Looking at my terms now, these terms are like, these terms are like, so I write them in standard form. The cubic terms, the m squared terms cancel, the mk squared terms cancel, and the k cubed term is my last bit. We have this perimeter problem, so let's draw a picture. Here's a rectangle. The length is 4x plus y. We don't know the width, but we know all the way around if we add it up, 4x plus y plus the width plus 4x plus y plus the other width, we would get the perimeter of 12x plus 6y. I'm literally just starting here and moving all the way around the rectangle, adding up all four sides. I'm calling the question mark W because we're in algebra and we like to use variables. All right, on the left I have 8x, I have 2y, and I have 2w. Remember, we're trying to find w. We want to know the width. Find the measure of the width. So I'm going to subtract 8x from both sides. I'm going to also subtract 2y from both sides. Two widths would be equal to this expression. If I divide by 2, one width would be equal to 2x plus 2y. Here's another one that's good to use a box, but a lot of people had trouble probably with the exponents in these terms. So we have a squared, negative 3ab, 2b squared. When I multiply them, I get a cubed, negative 3a squared b, 2ab squared, a squared b, again multiplying, negative 3ab squared, and 2b cubed. Now we look at like terms. A cubed, a squared b, ab squared, and b cubed. So I end up with a cubed. Negative 3 plus 1 is negative 2a squared b. 2 minus 3 ab squared would be negative ab squared plus 2b cubed. Take your time, make the box, keep track of those exponents, and you shouldn't have any trouble at all. And the final one, a binomial expansion. It is completely illegal to just distribute this exponent or apply this exponent to each piece inside because these are not factors now. They are terms because of this plus sign. The plus sign prohibits that. What this literally means is r plus 3 times r plus 3 times r plus 3 times r plus 3 times r plus 3. So if you wanted, you could box them. R3, R3, and then you would box the next two. And then you'd take those answers and you'd box those, and then ultimately multiply by that other binomial. That's going to take a lot of work. Instead, we use our shortcut with Pascal's triangle. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. It's to the fifth power. This is row 0, 1, 2, 3, 4, 5. That's the row I want. In other words, if it's to the fifth power, we want the row that has 6 numbers in it, because we're going to end up with 6 terms. Those are my coefficients. Then I take the first term. Then I take the second term. I put them all in parentheses, even though in this particular example, the parentheses are not necessary. But if we had a negative number or a more complicated term, the parentheses would save us. Then I add my exponents. 5, 4, 3, 2, 1, 0. 5, 4, 3, 2, 1, 0. Anything to the 0 power is 1, so I cross those off. And now I'm ready to just multiply all the way down the column. 1 times r to the 5th times 1 is r to the 5th. Multiplying down the second column. 5 times 3, 3 to the 1st is just 3. 5 times 3 is 15, r to the 4th. Going down the next column. And again, if you want to multiply this out first, you can and call that 9. 3 squared is 9. 9 times 10 makes 90. R cubed. The next column, again, that's 27. 3 cubed is 27 times 10 is 270. R squared. Running out of highlighter color, multiplying down this column. 3 to the 4th is 81. 81 times 5, 405. R. And then finally, for our last one, 3 to the 5th is 243, I believe. Let me double check it. Yep, 243. This is just 243 times 1 times 1. And that's how we get our final answer.